Okay, I've been working on trying to get these two sets of jumpers hooked up to these two sets of jumpers in a way that I can actually copy and paste it up the board, and I'm not having the greatest luck with that. That's not to say that I'm not having any luck. It's just taking some time to get it done. Well, so obviously I'm picking up right where I left off in the previous video. And I'll stick a link up in the corner here so that you can go back to that if you haven't seen it yet. I do recommend starting there because I'm not going to spend a whole lot of time explaining how I got to where I'm at. What I'm doing is I'm building a register backplane strip, and I'm going to interconnect several of those strips together. And I am well into the trace piece of this. The challenge I have is that it's taken a lot longer than I expected it to take, and so let's just keep right on going. All right, now the hope is be able to copy all of this. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. It's a mess to get cleaned up, and this is a mess to get cleaned up. Okay, so I've decided I want to keep the clear signals separated and handle them at the source appropriately. So I'm going to make those modifications here. Okay, so save it real quick. Rules check. Looks good. Let's see if there's changes, and there were. And so now I've got some problems here. Now I'm still dragging these down from the top. And the challenge is that there's just a lot of zooming in and zooming out, which I don't really want to subject everybody to. Okay, just a lot more of the same of that. So one of the things I want to look at here before I wrap this PC up is I want to just do a quick audit of all of these corners here. This is the bottom right corner, the outline here. Well, let me get rid of all the backfills. The outline here being the footprint of the PCB for the register, and then down here on the bottom I have this one power connection here that when I fill it with ground plane, I have, for this ground reference, I have just this little teeny tiny bit of ground plane here on the top layer. And then on the bottom layer, I've got a slightly larger piece, but it's connected by this one thin trace out to the rest of the ground plane here. I don't believe that's enough ground plane for my purposes here, so I want to see what I can do to improve the size of that. And part of that is going to be, for example, dragging, whoops, let's get the right thing here. Grab this track and drag it down. That should allow all of this to fill in. I need to double check and make sure I've not done anything silly with the vias that I've put in. And then I want to drag these upper layers out as well to give a little bit more room. Let's go for a smaller grid size here. And I think what that's going to allow me to do here, like I said, is to have a larger ground plane that comes into play here. So I want to take this and move this up just a smidge, and then I want to take this and move this. Now that won't go up. All right, let me rebuild this and see what it has for me. Okay, that's a little bit better, and I should be able to stitch that together. And this should give me better access to ground. If you look at my connections here, you can see the fill actually has 3 spokes for thermal relief here on the via and 3 spokes for thermal relief here on the capacitor. That's an improvement as well. Now I can go nuts trying to fill every little bit here, and it's not that it's absolutely required, but the more copper fill I have access to, the better things are going to work, I believe. That's my assumption going into this. So I'm looking for places like this that I can actually improve the top layer fill, and I probably could do it here as well. But the point here is to make everything one cohesive bit and not have these islands of ground plane. And I think that gives me a better result, because even though it's a complicated path to get there, I can get from this point here all the way up to here through a via to the opposite side through a via and get to that ground reference now, whereas before I could not. So that's an improved ground situation. Okay, let's label these registers here. So I can't label anything concretely, but what I have done at the bottom is labeled them A through F, and I want to make sure that I've got the same labels for each one of the actual areas. So let's drop in some text here. I'm going to call this A, and let's make this 25 millimeters wide, 25 millimeters tall, sorry, 12.5 wide. And we'll make this 0.2 millimeters thick. Let's see what that looks like. All right, let's change that. Let's make it 20 millimeters tall. Let's make it 15 millimeters wide and make it 0.3 millimeters. Let's make this right justified on the bottom. I'm okay with that move. And if I line this up there, that should give me what I need. Can I make that any thicker? So now I've got each register labeled so that I know which one of these control signals down here at the bottom I need to connect to. The last thing I need to do, if I zoom in here, or zoom way in, so this is the main bus up here at the top. So I need to also drop some text in here. That I want centered, I want towards the bottom. I am going to rotate that. And I'm going to get it centered right here on between 8 and 9. Now for the big test. Let's get my grid set up right. Okay, so main bus lines up correctly. Power and ground lines up correctly. ALU-A lines up correctly. Power and ground lines up correctly. ALU-B is all in alignment. Power and ground is all in alignment. Address bus 1 is good. Power and ground is good. Address bus 2 is good. And power and ground is also good. So I am happy with that. Double check, make sure I'm not, again, creating any problems. That's very good. Okay, well, that was a rather hard push to get all that PCB design done, all the schematics taken care of. But as I record this wrap up, the PCBs have been ordered, and I expect to have them delivered by the end of April, sometime before that, which means that you should see them in video form probably about the beginning of May. In the meantime, I've got a few things that I do need to take a look at, and so I'll be filling that gap with a couple of extra videos here. I've got my notes over here on my screen. There may be a problem with my jump instruction, and I need to set up a specific test to look at that. That's going to be our next video. And, well, I don't want to get too far into it, but ultimately, I don't know that it's fetching the right next instruction. And so I've got to test that out and make sure that I get that handled properly. The next major thing is to get into the ALU design and start breadboarding that out. Now, I do want to clean up some of the build and reduce the size of that so I can keep a lot of it in camera. But the ALU build is significant in that my timing is that I'm hoping to hit is that 1 cycle per instruction. And if it takes the ALU longer than 1 cycle to complete a computation, I'm going to have to come up with ways to get around that to maintain that 1 cycle per instruction. It's going to really make a determination of whether or not I can keep this at a risk-based single instruction per cycle, or if I actually have to pipeline it a little bit and have multiple stages in the pipeline versus just a single stage. So that's going to be a key component that I have to get to the bottom of, and that's going to be queued up behind the jump instruction debugging. I am unhappy with my clock module. If I had a choice, I'd chuck it right now and use something different. So I am going to come back around to that, and that's on the list of things to take care of. But one of the utility PCBs I just ordered is needed for that updated clock. So once I get that in, that's probably going to be one of the early things I take on, because it creates havoc in me trying to single step and debug and make sure that I'm getting things proper Sometimes it works and sometimes it just doesn't. And like I said, I'm unhappy with this design. I'm going to try something else and see if I can improve on that. And then, of course, I've got to install all the new PCBs and assemble them and do all of that stuff. So I've got the backplane I've got to get put together. Now, the backplane in and of itself is not going to be a very interesting video. But once I get the PC register in there and the R1 register in there and the fetch register into the build in PCB form, that is actually going to improve things quite a bit. So I do want to get those built, and I'm not going to do them all at once. I do want to show the build process because, again, I'm hand soldering SMD components onto a PCB, so the microscope will come back out and we'll get some footage of that as well. And that's ultimately what's coming up next. So we had a hard season of debugging, we had a hard season of KiCad design, and now we're going to go into a season of PCB building and integration into the build. And I think we're going to start seeing some improved results with that. And then, of course, we need to get the ALUs started. So I'll intersperse those so that it's not too much of one thing over and over and over again. Thank you for your time. We'll see you soon.